Welcome to our assignment presentation on the course Internet of Things about the topic motion detection using ESP32+CAM. I am Nandish Chandrasekhar and my batchmates are Adarsh Karan, Gautam and Hari Prakash. Let's start with the need for the project. The advancement of motion detection technologies has made them an integral part in allowing great amount of connectivity, even being managed by people's smartphone. And motion detection covers numerous applications which includes security purposes like intruder alarm, which works on some basic principle of securing entry points like doors and windows, as well as interior space containing valuable art like computers, guns and coin collections. It is also used in automation purposes like in hand dryers, which are built today have some sensor technologies in it. The push button is a product of the past as more awareness on hygiene and technology evolves. Current restroom design calls for as much motion sensor technologies as possible. It is also used in vehicle detection at barrier gates, which is present all around us. Take for example a theme park where a barrier gate is used during the drive in and out of the park. At these barrier gates, often a parking ticket is used. This also applies for toll roads where a ticket is used to activate the barrier gate. Moving on to the existing methodologies for motion detection, PIR sensor is used to pick up heat signatures from objects within their field of view. The sensor detects changes in the amount of infrared radiation it picks up, and when a threshold limit is reached, the sensor will trigger whatever it is connected to, be it light, alarm or camera. Video motion detection combines the images generated by a security camera with software that can analyze the images as they are captured. This takes place in much the same way as a camera operator sitting watching a video feed, but is automated and such holds the certain advantages. Thermal camera is also used in a way that they don't pick up visible light. To oversimplify, they are sensors that create an image based on temperature differences between objects in their field of vision. And the last one is radar, which works by transmitting radio waves and receiving the same waves bounced off objects in its field of detection.
The ESP32+CAM. So this ESP32+CAM is a very small microcontroller that comes with a camera module, and the resolution of this camera is about 2 megapixels. This module also has a micro SD card, so we can use it for storing a very small amount of video data. And the ESP32+CAM library also has object-oriented API that we can use with the inbuilt camera in the ESP32 microcontroller, which is the OV2640 camera. So it is usually used for applications like CCTV surveillance and to detect objects in the short range. So we have used it in order to detect motion. It is basically a very cheap module, and mission vision can easily be done with it. This is the block diagram of our project. So initially we have a laptop in which the the code runs in Arduino IDE. Then we have the CP2102 interface, which is basically what connects the laptop to the ESP32+CAM module. This CP2102 interface converts the USB data from a laptop into UART, so that it can easily connect to the ESP32+CAM. So this ESP32+CAM module has a camera, it is connected to a buzzer and an LED to indicate visual data, and the buzzer is used for audio signals. So whenever the camera detects motion, the buzzer goes on and the LED or the bulb starts blinking. Then we connect this ESP32+CAM to a mobile phone, and we have used Telegram for this purpose. The web indicates the IoT part. This is what makes our project an IoT project. So the ESP32+CAM can easily communicate with the Telegram app, and the user can get the required information from the Telegram app.
This is the hardware setup. This is ESP32+CAM, which is the microcontroller we are using here. In order to program this, we are using a CP2102 module, which is nothing but which converts USB data into UART data. Because this ESP32+CAM does not have any USB port, so the TX pin of the CP2102 is connected to the RX pin of the ESP32+CAM, and the RX pin of the CP2102 is connected to the TX pin of this ESP32+CAM. And the power VCC and ground are connected respectively. Here we are using the GPIO pin 13 and 15 here, 13 for the buzzer and 15 for the LED. So basically for motion alerting, we are using a buzzer and an LED. Next, let's see the code of motion detection. Here we are using some libraries in order to calculate the motion, and whenever there is a change in the frame, it will take for the motion. And after that, we are giving the LED and buzzer as output. And after that, it will checks for whether there is an error in the camera or not. So whenever there is a change in the frame, whenever there is a motion detector, we are making the LED and buzzer high, and after some delay we are making it low and making the camera free. So this is all about the working. So whenever there is a motion, an LED and the buzzer will be on and displaying a message as motion detected in the Arduino IDE. Now let's see the working. So whenever the car crosses the camera, we can see that the buzzer and the LED is on. So whenever there is change in the frame, the motion is detected. So this is the code for Telegram on request picture. So basically we have used Arduino header and Wi-Fi to connect with the Wi-Fi, and also we have used a universal Telegram bot in order to connect with the Telegram. So basically we are providing the SSID and password over here, and also we'll be having specific token for that bot, so we are providing it here, and also the chat ID. You can see here when we give /start, it will start the camera and the camera will be running. We can see the welcome and use the following commands to interact photo flash. So when we give flash, the flash will be on. When we give the photo, it will take a photo and it will send it to the Telegram bot itself. Okay, initially I'm clicking the start over here. So as you can see here, the start command is requested, and it will gives us welcome Gautam, use the following commands to interact with the ESP cam. So initially now I am taking a photo, so when I give /photo, the command request will be sent and connection successful. So it takes a picture and it sends to the Telegram bot. As you can see here, the car placed in front of the camera is taken picture and it's sent to the Telegram bot. It's basically a request response model, and when we turn on the flash, the flash will be on. As you can see here, the flash command is given and change flash LED state. Now let's see the picture. So again the photo request is given, and again it is takes a photo and it sends. As you can see, this picture is more clear than that of the previous one. So this shows that you can turn on the flash and take the images as you want. So this is basically the on request model.
Coming to the application part, is applied in the low-cost surveillance camera. The motion detector alarms are usually integrated with the burglar alarm, and when an unauthorized entry is detected, the alarm is triggered, thus giving indication about any threat that is going to happen. The motion detector lights are widely used because of the cost savings they offer. The automatic lighting based on human presence can save electricity in many situations where many of us forget to switch off the lights manually. It is also used in automatic sinks and toilet flusher, and also in hand dryers. Coming to the automatic doors and ticket gates, these gates work when a person reaches a field of a sensor. The door will automatically open and close again once a person is out of sensor's reach. It is also used in garage door openers. To conclude with, there are strengths and weaknesses to go with all these motion detection solution, and their effectiveness will be detected by the situations in which they are used, and the additional components that they are being used with. The visible light camera could be useless at night on its own, because the addition of motion sensor triggered light would vastly improve the performance. These motion detectors usually protect indoor areas where condition can be more closely controlled. The detectors for use in homes usually detect movements in spaces about 11 meter into 11 meter in area, whereas the detectors for large warehouses can protect areas with dimensions as large as 24 meter into 37 meter. That's all about the motion detection using ESP32+CAM. Thank you.